Hello. So, we will continue our discussion on cloud computing, rather we will continue our discussion on mobile cloud computing. So, what we are discussing about mobile cloud computing is that the mobile devices these days are omnipresent, right. There is a huge proliferation of smart mobile devices which has fairly good capability of doing lot of applications or running lot of applications. As there is a as the capability increases, the need for running more computational and data intensive applications also also there is a increase in those type of applications. Now, in though there is a increase in this resources of the mobile devices, but what we still feel that some of the cases had it been a backend some more computing services that could have been better, like execute some part here, some part offload some part of the computation or data on the backend devices, where what we have seen that cloud may play a important role. But there are several issues into the things, right, that any transfer of data and processes involves costing in terms of execution time, specifically that if the delay is more than something, it becomes unviable. Also, we see that there is a question of reliability when once your applications runs goes to another place to run. So, if there are a lot of dependency involves, like intermediate network or the wireless network, the availability of the resources at the other end, or failure or fault in the other end, and of course, the fault in the device at the mobile device itself. So, whereas when you offload, all those things come into play, right. There we have also seen there are issues of security, right. So far the application running your own device, so you have some ownership on the process and the data over it, right. But whenever the application running in some other premises or some other devices or cloud which is maintained and owned by some third party, then your there is a concern about privacy and other security issues regarding those data and processes. So, this becomes pretty tricky issue, and nevertheless mobile cloud computing is becoming pretty popular because of several reasons. First of all, you can now think of a large application running on, or rather controlled by a small devices. There can be things that your process may be using somebody else's data. So, you run somewhere where the data is there and the process is there, or the mobile device acts as a collection of data which is contributing to some central repository, some process at this device or some other device can do. So, there are issues of exchanging of data, interoperability issue, and sharing of this sort of devices, right. Or what we see a evolution of this, that internet of devices come into play, where cloud plays as a central role of managing the show, right. So, we will look at some of the aspects today regarding mobile cloud computing in continuation with our previous lecture on mobile cloud computing, and rather we will try to refer some of the research works which will give us a opportunity or give us a more better view of what are the different challenges and how to handle them, and so on and so forth. So, we will look at mobile cloud computing. As we have seen, some of the key challenges are that requires dynamic partition of an application to optimize energy saving execution time, right. So, two things as we mentioned earlier also, one is energy saving and to optimize the execution time, right. If the time is beyond a limit, then there may be that the process may not be viable to run on the things. Also requires software or something middleware that decides that the app launch, which parts of the application will be executed locally and which part of the application need to be executed on the externally or remotely or in the cloud, right. So, it is a classic optimization problem, right. So, we can do this sort of means dividing this application into different parts. Some of the parts or the component of the application need to be done locally and some of the remotely. This can be done statically, like I have a priori knowledge of this sort of things can be done, or in some cases I may not know the a priori that which need to be locally or remotely. Primarily it is if it is dependent on the data and other type of things, right. So, what will happen, I need to have a dynamic decision on the things, and as we understand, whenever we do this type of things, synchronization, scheduling and resource management come into play in a big way, right. So, all those things here, and when you are specifically doing the devices and say infrastructure which are owned and maintained by different authorities, then it is a more tricky issue, like mobile devices is something and cloud is maintained by other third party. Intermediate you have service provider who are again have a different type of authority. So, all those things makes a very complicated issue need to be solved. So, this is one of the work is as referred in this paper, there is mobile assistance using infrastructure, right. So, it is one form of MCC. So, MAUI enables the programmer to produce an initial partition of the program. So, programmer marks each method as remotable or not, that means whether it is remote or local. Native methods cannot be remotable, which are need to be done on the device itself. MAU framework uses the annotate to decide whether the method should be executed on cloud server to save energy and time to execute the thing, right. So, there are a couple of times, the time to execute on the cloud, there is a time to transfer this process and data to the cloud and get back the data if the need demands. And MAU server is a cloud component. So, there is a MAU client which is on the mobile side, there is a MAU server which is a cloud component. The framework has necessary software modules required for the workflow. So, that is a client server type of architecture where what they propose and can be able to synchronize. So, if you see, so there is the app and there is a profiler and the solver. Profiler basically profiling of the application, and profiler along with the solver partitions the application. This gets executed here and with RPC calls, and then it in a to and fro things, client server communicate to the profiler, sync among itself, and the apps run in some part on the app and some part on the device and some, or what we say smart mobile device or SMD, and some part on the cloud, right. So, there is another work which is what is called COMET, code offloading by migrating execution transparently, right. So, works on unmodified application, no source code required, that is on the app itself, allows threads to migrate between the machine depending on workload. They based on the things that threads can migrate. It implement a distributed memory, shared memory or DSM model to runtime engine, right. Those who have gone through computer architecture or advanced computer architecture and OS type of things, they understand that this DSM model. DSM allows transparently movement of the threads across machine. In computer architecture, DSM is a form of memory architecture where physically separate memories can address as one logically shared address space. That is the core of the, or that is the what we say very quick view on the what this DSM says. So, likewise there is a phone OS and remote OS. So, it need to maintain these memory states, and there is a distributed memory synchronization, and the executed these processes are the codes are executed or offloaded by migrating execution transparently. So, it is not that neither the source code is required, nor the user end there is known that these things are going on at the back end. So, what it requires only program binaries, right, execute multi-thread programs correctly. So, it does not require source code, only the binaries. Furthermore, improvement on the data traffic during migration is also possible by sending only parts of the heap that has been modified. So, it is not transmitting the whole heap, but the part of the heap which has been modified. So, what we see the key problem to address or solve is at its core MCC framework must solve how to partition a program, right, or execution on heterogeneous sources. So, not only partitioning, it need to be executed on heterogeneous resources, like it one on the mobile device side, which may be some mobile related OS. When you are running on the cloud side, that is some other kind of environment. So, it is a heterogeneous environment, how things need to be done, need to be looked into. So, it is a task partitioning problem, as we have seen in other computer architecture and organizations, widely studied in processor scheduling as a job scheduling problem also, right. We do have this sort of challenges out here. So, need to be looked into from that angle. So, task partitioning problems, so what we have typically in a task partitioning problem in MCC, a call graph representing the application's method or call sequence, right. So, it is a call graph. Attributes of each node in the graph denotes energy consumed to execute the method on the mobile device and energy consumed to transfer the program states to the remote server. So, one is the energy consumed in the mobile device and transfer the things. What we are considering that the other end, that is the cloud end, it is pretty resourceful and efficient. So, the energy consumption is in executing that in the cloud end is negligible in compared to the energy consumption at the this end, at the device end. Rather, the device does not much care about that, but it need to care about that executing its own locally the portion to be executed and the transfer cost of this say memory state and processes and so on and so forth as things required, right, and data and memory states and so on. So, output what we get as a partition the methods into two sets. One set of the method executes at the mobile device and the second set goes to the execute on the cloud. So, if we look at the goal and constraint, energy consumed must be minimized. So, I need to minimize the energy consumption. There is a limit on the execution time of the application. So, it should within the threshold say time capital T. Other constant could be some methods must executed on the mobile device, total monetary cost, etc. So, we have couple of constant, that means we need to goal is to reduce the energy consumption, time should be within that particular threshold value, and there can be other constant like some of the application, some part of the application may need to be executed in the device itself. I may not be able to offload it, and I may look at the total costing of the thing. The total cost should not execute some portion more than that. So, these things are necessary. So, if we look at that little mathematically, so we have a execution graph, right. Out of that what we say that these are V1, V4, V9 in this case are native task, that means it needs to be executed in the device itself, right. I cannot offload it. So, there can be highlighted nodes here must be executed device. Edges represent the sequence of execution, that how the sequence of execution will be there. Any non highlighted node can be executed either locally or on the mobile device, right, can be locally or on the mobile device. So, if it is offloaded to the local device, this first portion says that how much energy it could have saved, right, or in other sense had it been worked on the local, how much energy could have been taken. So, that has been saved if I offload it to the remote. But I need to also look at that where the costing of transfer this data, right. So, there is a cost involved or there is a energy cost involved, energy expenditure involved in transferring the data from the device to the remote device, right, that has to be incurred by the mobile device, right. So, that needs to be there. So, if we need to maximize this. So, if this result is a positive or the maximum if you can maximize, then I have a substantial energy saved, otherwise cannot be there is no benefit of doing that, right. And of course, it should be within a total execution latency should be less than L, right. We should not have this whatever we do need to be less than the particular latency L, right. So, that it should be within that particular things, and I need to look at that a dependency also, like execution of one need to be executed. If there is a dependency in the graph, that needs to be executed out here also. So, as we are discussing, there are two type of partitioning, one is static and dynamic. As we have seen, static, in case of static, when the application is launched, the invoke a ILP solver and which tells where each method should be executed. So, it says that statically says that when it is launched. So, there are also heuristic to find a solution faster, that there are we can deploy heuristic. In case of a dynamic or adaptive partitioning, what we do for a long running program, environmental conditions may vary, right. If it is executing for a long time, environmental condition may vary, like requirement of the data and even the availability of the remote resources, transferring bandwidth, all those things can vary. Depending on the input, the energy consumption of a method may vary. So, that means in other sense, I need to take a call that which partition need to be executed locally and remotely, because of that varying nature of the things. The costing may go on changing, right. So, that is another challenge out here. So, there are as we see, there are when we do this type of partitioning and transfer the job, execute something locally, something remotely, everything within a time limit, a particular threshold value, threshold time, and we want to maximize the energy saving, right. So, these are the different constants, and in order to achieve this sort of issues, so there are several challenges and issues need to be addressed. So, mobile communication issues, that is low bandwidth, one of the biggest issue, because of the radio resource of the wireless network is much more scarce than the wired network. So, it is the availability of this bandwidth, mobile bandwidth or wireless bandwidth is at times is pretty less in compared to a wired type of things, or so that is not only less, it also varies on if it is a long running means long running process, then it may vary over time. So, getting a guaranteed bandwidth is a challenge. Service availability, mobile user may not be able to connect to the cloud to obtain a service due to traffic congestion, network failure, mobile signal strength, and so on and so forth. Issue of heterogeneity, handling wireless connectivity with highly heterogeneous network to satisfy MCC requirement, always on connectivity, on demand scalability, energy efficiency is a difficult problem. So, there are heterogeneity involved in it, and these are different challenges. So, these are more issues with the communication issues. There are few computation issues or computing offloading related issues. This is one of the major feature of the things, like you able to offload it. Offloading is not always effective in saving energy, as we have seen that if those parameters are not made, then it may not be that energy saving may not be what we say within that quote unquote profitable margin, right. So, it may be costly stuff. It is critical to determine whether to offload and which portion of the source code to offload. So, it is a critical challenge, and especially as that there are different type of application with different type of requirement, etc., and it is a major challenge to decide that when to upload, how much to upload, and so on and so forth. So, there are other trials or other type of initiative. One is that code offloading using Cloudlet, right. So, if you look at Cloudlet, it is a trusted resource rich computer or cluster computer that is well connected to the internet and is available for use by nearby mobile devices. So, it is a what we say we can look at as a smaller version or of cloud, but it is resource rich, but it is more within the locality of the mobile devices or nearby regions, right. So, offloading a code to the remote server and executing it, when you look at the code offloading part. So, this architecture decreases latency by using single hop network and potentially lowers battery consumption using Wi-Fi, short range radio, broadband, wireless, etc. So, what we try to see that first of all offloading, and secondly when we make multiple hops, then the cost increases. So, what we try to see that whether I can have presence of smaller clouds which can take care of this sort of application, this sort of executing this portion of the application, and if we a single hop, then we can have something more, or what we say that we can have more better energy saving and better response time with having those resources much closer to the device. So, code offloading using Cloudlet. So, we have a mobile devices, mobile networks and the remote cloud, and there are, if you look at, there are different small different set of systems or mobile cloudlet and cloudlet nodes which takes care of these devices, right. Or what we say that goal is to reduce the latency in reaching the cloud service. Servers use servers that are closer to the mobile devices, that means going for, instead of the full fledged cloud, we can have smaller version of the clouds or cloudlet. A cloudlet is a new architectural element or that arises from the convergence of mobile computing and cloud computing, right. It represents a middle tier of a 3-tier architecture like mobile devices, cloudlet and cloud. So, that in other sense what we are trying to do in order to reduce the latency and better energy savings, possible better energy saving, in between one side the cloud is there, one side devices, we made a make a intermediate thing what we say cloudlet, right. So, which takes care of the things. Now, when to upload is again a serious question. So, if we look at a very straightforward formulation of the things. So, if we look at that equation, that so what we say that PC is the energy cost per second when the mobile phone is doing computing, that means mobile phone is computing. Pi is that energy cost the mobile phone is idle. PTR is the per second cost per second when the mobile phone is transmitting data. So, a mobile device can be either computing or idle or transmitting data. So, these three components are PC, Pi or PTR, or when energy when transmitting data. Now, if you consider C as the number of instruction and M is the speed of the mobile compute the C instruction. So, what we see that if we see that PC C by M, if it is offloaded, PC C by M minus Pi C by S. So, what is S? The speed of cloud to compute the C instruction. So, if it is S is the S is the speed of the cloud, then we can see that idle Pi is the idle time, C that is number of instruction by the speed. So, this P by C by S, and the transmitting PTR D by B, D is the total data to transmit and B is the bandwidth available. So, if we offload, so this is my overall ballpark figure, right. This should be a positive number. So, it says that I save energy, right. So, this was my energy consumption. If I offload, these consumption are not there, and then this is saving of the energy. Or if I say the server or the cloud server is f time faster, then I can look at S equal to f into m, right. So, that means your speed of cloud to compute C instruction, and m is the speed of mobile phone to compute C instruction. If it is f times faster, and we can see that S equal to f into m, right. Or in other, we can rewrite the program or rewrite that particular formula, or substitute this is equal to f by m into the formula to look to basically arrive this thing, C by m P C P I by f minus P T R d B I B. This is very simple arithmetic. You just substitute, and if you take appropriate common, so we come to a figure called in this sort of scenario, right. C by m equal to P C minus P I by f and minus T R. So, what we see from here, that energy is saved when formula produces a positive number, definitely. If it is a positive, then only energy is saved. The formula is positive if d by b is sufficiently small compared to C by m, right. So, one side is d by b should be sufficiently small compared to C by m, so that I have a larger number on the left side. So, this is what we say that this is one of the condition. Cloud computing. So, what cloud computing can potentially save energy from the mobile devices. Note that all application in the energy efficient when migrated to the cloud and may not be energy efficient, right. So, from this formula what I say that first of all d by b should be much less than C by m, and f should be sufficiently higher, which makes sense, right. F is the how many times the cloud server is faster than the mobile device, it is likely that the cloud server should be sufficiently higher. Otherwise, there is no point in offloading and getting executed externally, right, if it is not. So, if that conditions are satisfied, then what we see that we get a positive number, and it is obvious that all the applications may not be always beneficial when we offload. Cloud computing service should be significantly different from the cloud services for desktop, because they must offer energy savings in this case. The services should consider the energy overhead for privacy, security, reliability, data communication, etc., which we have not directly considered in these cases. So, it's ideally it should take care of other type of features which while calculating the things. So, if we look into different other way of looking at the same formula is that offloading is beneficial when a large amount of computation C are needed with relatively small amount of data communication, right. So, we require large amount of computation, right, with relatively less transmission of data, right. Here also, as we have seen, that C should be sufficiently large with D should be sufficiently small, keeping like F must be much faster, and we see that it is a things, and we can see that in different scenario how things will be there, right. So, computation overloading, there are several approaches, you can see several research papers also. Partitioning a program based on estimation of energy consumption before execution. So, what we say that partition estimation of the thing. Optimal program partitioning for offloading is dynamically calculated based on trade off between communication and computational cost at runtime. Offloading scheme based on profiling information about computation time, data sharing at the level of procedure calls, right. So, at the level of procedure calls we can do. So, a cost graph can be generated or constructed, and branch and bound algorithm to apply to minimize the total energy consumption of computation and total data requirement. So, what we are looking at that it is not vanilla offloading some of the things to the things. So, there are a lot of calculation involved as we come back to our previous premise, that one is that your energy savings should be higher, need to be maximized, whereas your latency should be preserved, and we see that there are several other aspects of the components are there, like security, reliability, fault in the server system, etc. And there are issues which are not directly under may not be directly under the control of the cloud, neither on the mobile devices, which is what we say that intermediate wireless network, that also plays a thing. So, there are issues of heterogeneity need to be addressed and need to be looked into in totality. It is not that isolated I offload something, get some executed and type of things, need to be looked at as in totality, so that the user at the mobile end or the user get a seamless feeling or better resource utilization or better energy savings at the things. Thank you.